Hello and welcome to the 2021 Setty Foundation Applied Engineering Challenge for the HVAC&R Senior Project. The project was completed by myself, Dean Smith, Mary Kelly Ogan, Blake Matsura, and Zach Peterson. The 2021 SETI Family Foundation Applied Engineering Challenge is to design an indoor grow facility. The team was tasked with ensuring that the facility would meet local requirements. The building must also fit a selection of building types with a limit on a single family residency being limited to 4,000 square feet for the property and a limit of 20,000 square feet for a multifamily facility, depending on what the team chose. These constraints were to provide the general framework, and the rest of the project scope was to be determined by the team through the process of the design. The team first moved to determine a facility location and type, settling on the local community of San Luis Obispo. This provided crucial weather and climate data and also led the team to determine that a single family residency would be more applicable to San Luis Obispo and the surrounding area, as there are more homes of this type. Following this, the team created a new construction concept design for their facility, limiting the floor size to 1,000 square feet to keep the family house and grow facility within the 4,000 square foot constraints. The team decided to make the facility with the intent to maximize the abundant sunlight San Luis Obispo receives year round while still providing the controlled environment of an indoor grow facility. The design looked to include large windows, indoor plumbing fixtures and drainage, standard building heating and cooling systems, and artificial lighting to stimulate nighttime growth. Following this, the team moved to design the airside and waterside systems, with the first step being to further determine local building requirements and needs for the new structures. The County of San Luis Obispo used 2019 California Title 24 codes as their primary regulations for structure construction and systems, and as such, these were followed during the design. The team also conducted extensive plant research to ensure that the designed system would handle the increased humidity and latent cooling caused by the plants. Further, the team wanted to open the system to maintain temperatures that will allow for plant growth and non-native flora that cannot typically grow in San Luis Obispo. With this information, a building model was constructed in Revit to allow for building takeoffs and load calculations, as well as provide a space to lay out the necessary systems for a final project. The building loads were computed using the program Trace, and using local climate information, the maximum building heating and cooling loads were calculated, with the cooling and humidity from the plants included within the calculation itself as a separate loads, so the program could give valuable information. With all necessary calculations and steps completed, the system equipment for the indoor grow facility was selected and inserted into the model, with train equipment for both the condensing unit and the air handler being selected. Preliminary building construction documents were also made for both the plumbing and the mechanical systems to include all fixtures and necessary equipment. In conclusion, the system for the indoor grow facility was constructed and finalized within the Revit model. The system should all work and meet requirements to stimulate the growth of the plants, all while maintaining a controlled environment. Should also be noted, though, that if the construction of this facility starts after 2023, California will be updating the necessary Title 24 energy codes to include more strict requirements on indoor grow facilities that currently do not exist and have not yet been defined. And as such, the system may have to be adjusted at that time.